Greetings. Grateful to have you join us today for a chat with Nick Landers, who is co-founder of Dreadnode. And Nick has joined us as part of an ongoing series of AI security interviews, and I'm delighted to know Nick and to interview him about Dreadnode, about some of the AI security things that he's found during his time there and previously. Nick, welcome.
Yeah, thank you. I appreciate you having me. I'm not sure, do you want a longer introduction or
I want the longer introduction. Nick,
yeah,
tell me about you. Tell me about Dreadnode.
excellent. Yeah, so I was originally a security operator, sort of pen tester into the red teaming space and kind of graduated into malware development, exploit dev, and I've spent, most of my professional career in advanced security, taught courses about the material. And yeah, my co-founder, Will Pierce, is a longtime passionate AI guy. And about 5 years ago, he was interested in the space, gave me a little bit of an introduction. We did some early work and kind of parted ways. And he went on to Microsoft and NVIDIA. And we just essentially reconnected last year. And, obviously, Will sort of predicted this need for the merging of AI and security communities coming together. And yeah, we decided we were going to pull the trigger. And so our company kind of focuses on just everything at that intersection. So, we're trying to speak to the people who come from the machine learning space, traditionally data scientists or ML ops engineers, and also to people who would be in security who are now being asked to test this new technology. And this isn't something new for security. I mean, get new technologies all the time, cloud stacks or blockchain-based systems. And yeah, every time there's a new big technological shift that brings in security people and people who are traditionally maybe engineers or researchers in the space, you get a new sub-community of security, right? So there's like cloud security community now of people who focus on that. There's, smart contract auditing, blockchain security experts. So yeah, we really want to help kind of grow the community of AI security experts. And, we tend to, stay pretty technical with things. Both Will and I's backgrounds are in traditional security, so we have a lot to learn about the machine learning space. But yeah, that's kind of our mission and our goal. And, I'm sure there's a lot of different approaches, and this space is wide open. The field has a ton of space available for experts and companies and people building products and solutions and sharing information. So we just kind of want to participate in that.
And Nick, I mean, I've heard you say the word community a lot with respect to Dreadnode. It's you've been involved in the community for a long time, but also you have products and services that you're offering. You're doing some trainings. Can you talk about some of the things you're involved with there?
Yeah, I mean, I think the space is dynamic, right? It's like everybody knows that when you're in new technologies like this, especially as they keep moving faster and faster every single time they come around, um, I think we, yeah, want to focus on building up both an audience of people who would use products and services, think like AI red teamers or machine learning engineers who now need to work on securing models or at least be versed in adversarial attacks or the abuse or misuse of their models. And yeah, our products and services kind of center in a few different sub areas, subspaces there, ranging from like training platforms and what the equivalent of a capture the flag environment would be, but more AI focused security, up to tooling for red team operators, and then more on the cyber evals, testing the capabilities of offensive workflows that applies to models. And yeah, that's in probably poor form. I have no like formal pitch. I think I'll probably be doing something else in 3 months or 6 months than I would even say today. But yeah, I think the center point for us is just focusing on the people who are coming into that subspace and making sure that it grows in a healthy way, right? Like that's well informed and people have resources available to them, because they're ultimately going to be the ones making the long-term decisions for how we use this technology and how we secure it, and making sure people are using it safely.
Great. I promise like the last introductory question about Dreadnode, but if our listeners were to go to dreadnode.io, they'd number one, first thing they'd see this super sick logo. Can you tell me about it?
Yeah, I think when Will and I started the company, we have never done a company before, and I think there's this hurdle you have to get over of offloading things that you would typically want to just take care of yourself, being senior technical consultants and working in, traditional software engineering fields. There's kind of this do-it-yourself attitude. And yeah, we ended up just throwing some ideas out and used a site where people could spend a few weeks submitting suggestions to us, and it panned out really well. We ended up finding some stuff we liked. So, it was like $1,000 or something like that. And I think it's well worth it for a designer time. So if anybody's looking for logos to be built, and maybe you feel keen on designing them yourself, as I have a design background, maybe avoid that and go and pay somebody to do it, because you might end up happier with it. So I suppose not as interesting of a backstory, but there's certainly a pirate theme going on, and that just stems from old days when Will and I worked together. That's a very, hacker subculture of
Yeah.
seeing yourself as the renegades almost. And we try to keep the spirit roughly alive without it being overbearing.
And true to form, it's more fun to be a pirate than to join the Navy, and that's well
Yes.
alive in your logo.
Yeah, yeah, absolutely. And I think it speaks to for however sort of cliche it is, it's attackers don't think within the bounds of rules, right? And that's I always describe the difference between um the technical prowess or the technical focus of security engineers versus traditional engineers as being constructive versus deconstructive. Engineers are looking to build something and make something, and that's an amazing thing, and we need lots of that. And security folks tend to bring this attitude of like deconstructing things to understand how they work. And that's kind of counter, I guess it goes against, progress to some sense, right? It's
Yes.
finding the strange hidden corners of things and the strange ways rules interact. And so yeah, I think piratey things sort of speak to that a little bit.
Well, like today, I wanted to talk about for our audience like three broad buckets of topics. One are
Mhm,
about some things you've discovered at the boundary of security and machine learning. The second would be about kind of some of the tooling practices that I know, Nick, you especially have some expertise in.
mhm,
And the last big bucket would be around some of the more general, interesting thoughts that live at this really unique space at the boundary of machine learning and AI.
mhm.
So, like the math and the practice are oil and water, and you're finding some really interesting things at that intersection. I want to talk about for the third part.
Yeah, yeah.
So, part number one, do you want to just, I know there are a couple of several things we could talk through. Do you want to just enumerate some of the interesting kinds of discoveries that you are seeing, especially as we see LLMs, open source models come into like the conscience of the public, into
Mhm.
the conscience of enterprise developers? What are the security things that you're discovering or have discovered as these are being adopted?
Yeah, I think, there's the traditional security space when it meets a new technology. I think the first thing that happens is there's a lot of supporting technology around machine learning that has really nothing to do with machine learning as a concept. Like behind every model is an inference endpoint and an API server and a Docker container and a cloud environment. And, all of those are spaces that the security groups are already familiar with. And so, kind of you think all the way back at the beginning and build, the first place to start would just be finding traditional issues that relate to machine learning systems, but they're not necessarily new issues. And I think it just comes about as people are adopting technology quickly, and the process, the sort of grind of security, takes a long time, and it's a big commitment on the part of the groups making these models. So we've done research that applies like open source intelligence into systems that would be deployed online. It's a very classic strategy that attackers use. And typically the issues you find there just relate to, limited authentication or, indirect object references issues. There's, concerns about whether or not a semi-privileged user in a system could elevate to higher privileges, and most of it comes down to like web application permissions. As you get more into machine learning integrated systems, and one of the items we took a look at was in OpenAI's what they now refer to as just GPTs or their custom GPTs. Um, the system was kind of in beta for a long time, and they now just recently sort of published out the broader store. And there's this, I don't know if it's an implicit layer of security that gets laid on users when they're in a backend dashboard building one of these. But you get control over what the model is doing to some degree. Like you get to write a prompt for the model and maybe upload files. And there's not a ton of clarity to the users building these systems about where that data goes or how it will be accessible. And I think for an average user, when they're building something in the back end of a system to be deployed on a public side, they assume that most of the stuff they're putting in there is secure, or at least, wouldn't be easily accessible. And a lot of our research just dove into the way these underlying APIs work on the OpenAI end. There was manifest files and sort of descriptions for all of these GPTs if you had the IDs that you could go and enumerate. That included information about file IDs that were all the uploaded files into these custom GPTs. And then they had endpoints that would allow you to essentially pull down a file if you had the ID. And all of this stems down to fundamental API security concerns of like, maybe they assumed those IDs would be private, or maybe an endpoint over here uses those file IDs and lets users download them, but there was never an assumption that you would have a file ID that didn't belong to you. And yeah, we reported that issue to OpenAI. And I think it's probably a good example of these pretty basic web application vulns or app layer vulnerabilities that kind of plague or have been plaguing these early model releases or systems that are providing more integrated uses of these models beyond just inference, right? Where you can upload files and give context and share conversations and share versions of your GPTs. And companies like OpenAI are moving extremely fast. So it's not at all surprising that stuff like that gets missed. But yeah, it's kind of tier one of security. And there's a lot of that still to do for people who, I think there's a lot of security people, and to speak to them directly, I would just tell them, you don't necessarily have to know a lot about the internals of machine learning to come make a difference in this space. So yeah, I guess that's kind of an overview and broad thoughts on, maybe early introductions for people into this space and, where they could get started.
Let me ask about a few of these in particular that I think are super interesting. So you mentioned OpenAI GPTs,
Mm.
um, that these are configured services, but that one can query in natural English.
Mhm.
The way that these are exposed, you discovered some of these, let's call them configs or even secrets inside them. You discovered them how? What about the AI allowed this leakage of config?
Yeah, I think that's kind of the interesting element is you hear about a vuln in a system like this, and your immediate assumption is like, oh, was it a jailbreak or did you like get the model to misbehave in some way? But no, fundamentally, it was all API layer work. So, you create a new GPT and it gets a unique identifier that's prefixed with a G. So you'll often see them G dash and then some,
Mhm.
8-character alphanumeric code. And before the store was released, there wasn't like a public repository of them. If you obviously made a GPT or you had a link to an existing one, in the backend, what would happen when you pulled up that GPT's page is there was a big like settings config that would get pulled off the API that described like everything about that GPT. So what model it was using in the backend, if you had services configured, like it was able to make web requests out and like access external APIs, that full API schema would be in there. Any file IDs that you had uploaded, whether or not the GPT had code interpreter enabled. And like, I don't necessarily know if these things were considered sensitive or public. But obviously the IDs were maybe hard to come across. And so essentially we just went to all these public repositories of, people cloning a GPT store, indexing them, scraped, I think, something like 20,000 or something GPTs out, and effectively just ran through and built out a huge file of all of these entries. And then we started playing with what happens in the backend when you interact with them. A few of the things we noticed was like in the backend, you can kind of watch internal API calls, or I wouldn't call them APIs. I would almost call them interfaces or components be exchanged, messages get exchanged between different backend services in the model. So like, you'll get a post into a long running string that says the user sent this message, and then that message might get processed, and there's some backend system that identifies that the user asked for a file and then triggers like the loading of all of the files of that GPT into the code interpreter environment so that the model can start using them. And a lot of this stuff is just kind of excessively noisy. Like anybody who would pull open a monitoring tool and watch the HTTP traffic can see a lot of really interesting things going on in the back end. And I think that's sort of the premise of these vulns is, if you have that information and suddenly you're thinking about this as just an API layer issue, We were able to get the models to sort of coerce the models into dropping the files into the code interpreter environment first, and that's a little non-deterministic. And there was some questions about scaling that up, and then we eventually just found that there was a free API endpoint you could go to, and you could pull down files for any GPT that was uploaded with just its identifier, of which we had, probably 100,000
Mm.
of them that we could go and look at. Most of them were like reference files, or some of them were instructions, people trying to like protect the GPT against jailbreaking. We didn't find anything that was like excessively sensitive outside of maybe some API keys here and there. And OpenAI did fix the issue, so clearly they, thought that was a concern. But yeah, kind of, you know, seems like it would be more of a model issue, and then it just kind of falls down into the API layer, which is just really funny. I think that's classic for new technology. It's like you want it to be this cool, really novel that involves models, but there's still a lot of just really basic, trivial stuff.
Super interesting. So you mentioned GPTs. You also mentioned like open ports and Jupyter notebooks that are
Mhm.
exposed to the public web
Mhm.
that can be discovered with traditional cyber tooling. I think another one we've talked about in the past, Nick, are the resurrected Pickle vulnerabilities from
Yes, the
whenever,
classic.
2011 or something,
Mhm.
now alive and well in the PyTorch file format.
Yeah.
And right, did you any comment you want to make on that and the prevalence?
I'm not sure. I mean, I think the community is making good steps away from them. It reminds me a lot of deserialization vulns in the Java ecosystem or the .NET ecosystem. Serialization is just a really tricky thing to get right. There's this inherent tension between you want the serialization to be flexible enough to represent to use a machine learning term, out of domain data, but obviously that out of domain data, or the less filtering or limitations you put on it, the more dangerous it potentially becomes. So yeah, we've done, quite a bit of work in that space. A lot of it has kind of just come down to the filtering logic that people are applying on top of these pickles. And, there's a lot of really well documented write-ups and descriptions of really common ways that you can abuse pickle files. And those common write-ups and descriptions get turned into detection techniques. Like, for instance, Hugging Face now has like a pickle detector where if you upload a file and it has a pickling component in it, the web UI will sort of show you what objects or class instances are being produced from that. But for a lot of these people, they haven't actually dug into the raw spec of pickle files and looked at exactly what they do, or old versions of the protocol and different ways to get around object creation. There's the strategy that gets implemented a lot when deserialization becomes an issue, which is like whitelisting and blacklisting, or allow listing and deny listing. I think that these sorts of elements are good stopgaps, but we tried that in Java, we tried it in .NET. It doesn't pan out at the end of the day. You end up with a half-baked solution that just requires a motivated attacker to get around. So, we have some POCs for pickle files that, get execution a bunch of different ways, and they bypass those detections, and any other motivated attacker could create them as well. So
Very
yeah, I think
classic cat and mouse of cybersecurity
yes,
there, right?
yeah, and it's just better to shut it down, right? It's like safe tensors and more modern like Onyx formats for model files. Like ultimately, these models probably don't need to represent raw code most of the time. We have more standardized libraries now, and the weights can be interpreted as linear layers and particular activations and weights and whatnot. So yeah, I hope we make better progress in that front. I think for us, pickle files have always felt like that, almost the silly thing that is a big deal, but at the end of the day, it's almost played out, right? You would tell somebody that there's a vulnerability because they're deserializing a pickle, and it's kind of obvious. I think where the concern is for me is if people are thinking that these sorts of detection lists, or you know, um, classes or code that inspect pickle files and try to determine if they are or aren't dangerous, like those will never pan out. And I don't think that that's a good solution that we should be pursuing. And I think, I would hate to see the same lessons repeat themselves from, other serialization security components. Like Microsoft is now deprecating the binary formatter serializer in .NET Core because it's been a consistent issue for them for years. Tried a lot of different ways to make it safe, and it just doesn't work.
Yeah. Nick, I want to shift gears. We've talked a lot about things that let's call the realm of traditional cybersecurity as applies
Yes.
to today. I want to shift to the other side. Some of the
Uh,
some of the discussions that we can have about adversarial machine learning attacks and how that might affect security. I know,
Mhm.
in particular, you've put a lot of work into decomposing these kinds of attacks into, instead of monolithic algorithms, into pieces that can be composed to achieve certain outcomes. So can we first step back? Can you define for me what is an adversarial machine learning attack? Why is it important for security? And then let's get into the engineering practices.
Yeah, actually, this might be an interesting question. You're as experienced in the space, probably more so in many ways than even I am, especially in the literature and whatnot. I guess I'd be curious how you would define an adversarial attack. Like, is there some fundamental description that you feel like is most appropriate? And I kind of want to start there and work off of it because we're now moving into a space where, I mean, my background is in security engineering, and I've been learning a lot about the algorithms and attacks and implementations in this space, but even I feel a little unconfident in the way I would describe, these. I feel like I could just as easily be corrected, by a swift lookup on archive on some definition.
Right.
And not that that's a bad thing. Like I don't think that should discourage anybody either. Like the academic side is its own beast. But yeah, how do you think of
Do you know,
adversarial attacks?
well, why don't we go with the broadest definition, which is the most encompassing, in which adversary doesn't mean like a bad attacker. It just
Mhm.
means anybody who is presenting the machine learning model with conditions for which it wasn't intended for.
Okay, interesting.
So in that case, adversarial machine learning explores the worst case conditions of a model. Whether that's a friend or a foe, it's just presenting to the input of, or in other ways, presenting this model something that it's wasn't designed for. Um,
Uh, yeah, that sounds good.
so
Um,
with
yeah,
that, my question is like, why is this a security concern? Like, how do you frame this in a security context?
yeah, I think that's a really good place to start. And I think it brings us to some fundamental terminology, and there will be give and take. I think the first impression for a lot of security people coming into the AI space will be, both disciplines have their own terms, their own way of describing, whether it's attacks or the particular actors in them or techniques. And there will have to be like a new shared terminology we use. I think for a long time, adversarial machine learning was kind of boxed into um, evil attacker, right? It's like it was everything that had to do with using or interacting with machine learning maliciously. And I think that definition of adversarial and just thinking about models being given inputs that are outside of its expected set of inputs is like a much better definition. And I think a better term that would be used to describe the subspace that we're trying to operate in is like, I don't know if offensive ML is going to be the term that ends up sticking, but kind of the idea that adversarial machine learning is useful for a lot of different things, like robustness and making sure that the model is behaving on out of domain data. Like adversarial is just taking sort of an aggressive approach to finding gaps in an algorithm's ability, kind of in the same way that you would do write test suites for an API. It's like the issues you might find in an API could be an integer parsing error. And like that on its own is not a security concern. It's just it's the API functioning inappropriately, like for a given input. And that's kind of nested underneath security to some degree. And yeah, adversarial machine learning is a particularly useful set of techniques for attackers if they want them to be. But I wouldn't describe it as like the end all be all of like
Mm,
how these systems could be exploited or flawed. I mean, just as we talked about in the sort of the prior 20 minutes, I mean, there's API layers that sit behind the model can make even a larger difference than adversarial attacks themselves. But yeah, I guess I like that definition. I think my introduction to adversarial machine learning was very much that, and I recommend everybody go through this, by the way. It's very incredible, but you'll have a model like an image classifier, and you give it data, and the image looks like exactly what you think, like maybe it's a car or something, and the classifier prints out car, and it's working exactly like machine learning should. And these adversarial attacks are so interesting because they explore this latent space in the model and find like really novel interactions. And it takes very little before, as a human, you're looking at an image that looks exactly the same. It looks just like a car and maybe even the same car. and the model outputs something not only different, but so confidently different that it is clearly seeing the world differently than you are. And I think that kind of leads me to the intuition and something I'm feeling kind of passionate about. And I think it's this nature of security operates best when we deconstruct technology down to its underlying, I would refer to them as protocols. Security often works in that space, like web security. For a lot of people, they think of the web as pulling up a browser and opening a website. Attackers and, by extension, engineers really think about that interaction as happening as discrete HTTP requests with headers and data and API endpoints and routing and forwarding and gateways. And almost all of the really novel attacks in the application space occur at that level. They don't occur by like clicking a certain button and the web app suddenly lets you get admin mode. I mean, maybe in the old days of throwing a tick mark in a field and getting SQL injection. And I think that is needed on the machine learning front too. And I think that intuition you get when you see an adversarial attack work and that amazing feeling you have when you realize that the model sees the data it's looking at completely different than you do. Like you're looking at an image, but underneath that image is being deconstructed into a series of bits in this tensor, that's like fixed and their float values of a particular size and fidelity. And each position in that tensor means something different about the position of the image or the type of subdata in the image. And to a human, those things can look exactly the same, but the data, small differences in the underlying protocol mean a lot for the model. And so when I think about tooling and building implementations of these attacks, that's sort of a guiding principle that I like to pursue,
I,
which is
I love that. And it's also not it's not specific to images. It's also
mm,
true for LLM attacks.
yeah,
The model is actually not reading text, is it?
yes, yeah,
It's being
absolutely.
decomposed into tokens, and those tokens become tensors. And
Mhm.
so the same meaning now, like the sentence reads slightly differently, but the same meaning is interpreted very different numerically by the model, right?
Yes. I definitely think that intuition about protocols and thinking deeper about LLMs is just something good for the audience to take home. I mean, we are exposed to these models in their text form 99% of the time. And we're already seeing the cracks start to open with, tricks around hidden characters in these tokenization fields. And I'm sure attacks will continue to improve with like multimodal LLMs and embedding models. Um, you know, Things where manipulations are occurring in the space beyond the discrete, right? Like into the continuous space, because functionally text embeddings are that continuous space, right? It's the embeddings model or models for embeddings are typically just an LLM with the back half chopped off, right? It's just you process a set of discrete inputs up to a window size into a dimensional tensor that represents in some very abstract way that text to mean something. And, that's ultimately what gets passed forward. So, yeah, if people are wanting to get into this space or really interested in those sub elements, I think that's a place to focus, especially because LLM security is becoming such a well, it is the hot topic, right? But those are where like a lot of the traditional adversarial algorithms would apply. Like there's a lot of amazing algorithms that work in those continuous spaces, and they're very efficient and very good at what they do. And the minute you can get there for an LLM, they work almost flawlessly, which is really neat. I think the sort of place I'll take it next is this concept of operationalizing the attack code or the algorithm code. Oftentimes in a research scenario, your primary goal is to produce results that are not only interesting, but like, have scientific value. In other words, are trying to minimize some error rate. Maybe you're taking an image and you're doing an adversarial attack and your measurement is L2 distance or something between the image that was classified correctly and the first image within a particular distance that's classified incorrectly. As attackers, we have slightly different interests in that space. And I see this difference in focus when even as an attacker, start to come into these adversarial attacks. My questions start to become more around like, well, how many queries does it take? And how efficiently am I making those queries? And how noisy are those queries? And I know, you guys at Robust have given this quite a bit of thought. You think about like, okay, well, if an attacker is attempting to cause a model to misclassify, one of the ways you could watch for that is by looking for signatures of these attacks in the input spaces, right? It's, you have an image and maybe somebody's trying to extract a model or bypass a classification. And, these attacks that are built in an academic space aren't designed to be stealthy, right? That's not their job. They shouldn't be either. In the same way that, as an attacker, I can write a web shell that uses TCP libraries, and those TCP libraries were not written at all with my concerns in mind about making it stable or reversing through a NAT gateway or something like that. And so, yeah, there's a really fascinating, I think, next generation of tooling that will be premised on making this academic research and all these amazing algorithms really focused more on what attackers typically care about, which is like efficiency and stealth, especially in a red teaming space, not a pen testing space where your job is to test a process, not necessarily a technology. And that process would involve getting detected, right? Like uh, to go back to terminology, and I'm not sure where the AI security community is going to fall on this point, but in the security community, we refer to red teaming exclusively as testing processes. So you red team the process of defenders detecting your actions and taking resolutions about those actions. It involves testing the technology because the actions you're taking are malicious in a network. Um, and on the AI side, red teaming has just kind of taken on this meaning of almost an extension of adversarial research, right? Where you're like getting
Yes.
a model to misbehave with particular inputs. And it's pretty human driven, and automated red teaming could maybe be seen as synonymous with like scanning in the security community. And I don't necessarily think the terminology matters all that much where people settle. But it's worth calling out that, the term red teaming can mean a few different things. And when we think about building tools for AI red teamers, we don't think about building scanners or tools to automate something in a most comprehensive way. Instead, we really think of human-driven tools, tools for technical operators who are trying to really press against the limits of detection and efficiency in their ability to attack these models, which is kind of a stark contrast. So that was
That it,
probably a long.
no,
I
that's super useful. I think, words are symbols and ultimately
Mm.
defined by how we use them,
Yeah.
but it bears, it's worthwhile to understand how you're using that word, Nick, as a red teamer is probably really different than what, a machine learning team is saying when they mean
Yes.
red teaming. For those of you listening, we have just been through this whirlwind of machine learning jargon, of security jargon for the
Oh
security
yes.
side.
Sorry, I didn't
We've
even.
talked about tensors and optimization and L2. There's a lot of stuff in here. You're not going to find a lot of people quite like Nick Landers who can juggle these concepts with equal fluency. Um, Nick, as we're concluding today, um, is there anything that you like to promote? How can people learn more about Dreadnode and the work that you do?
I mean, honestly, I think the best space for me to place my energy is just in really reinforcing that the AI security community needs more people all the way around. It needs machine learning people, it needs executives, it needs managers, it needs everybody to come together and really start to firm up what it means to help secure this technology. We have a lot of exciting things on the horizon, and I'd recommend people just follow us on Twitter, keep your thumb on the pulse. I'm sure we'll show up at some point. But really, I think my core message is if you are interested in machine learning or have classically been trained in that field and are curious about security, come and, meet in the middle. Come, get involved in this sub community and learn more about security and their terminology. And I would say the same thing for security people. I think a lot of them get scared about what it means to test machine learning, or maybe they feel apprehensive about the technology because they see it as not up to their level, or maybe not in the spaces they usually operate with. They're used to pen testing networks, not pen testing models. But their experience is super valuable too. Like
Yeah.
there's a lot of new questions we have to answer. So yeah, I hope despite the jargon, which I'll apologize to the audience for, I think I can't help myself to some degree. You should know that I didn't know most of that 8 months ago. And I still have a ton to learn, and I'm not well educated in this field. But I think it's a really interesting and fun subspace to exist in. And, companies like Dreadnode and Robust Intelligence are partners in building that space. And like, it's a really nice subspace at the moment because as my co-founder Will says, the tide lifts all boats. And so it's all of our jobs to like help communicate and facilitate knowledge sharing, and help smarter people than us, well, I'm sure there are a lot of, come in and solve much harder problems, that we'll probably never get to. So I guess that's what I would use my podium time for.
Perfect, Nick. Thank you so much for joining us. Love that you called out the need for partnerships. Dreadnode and Robust Intelligence are both in this mode of having a rising tide to lift all boats.
Yes. Yeah.
At Robust Intelligence, like we're doing this on the defensive side. We're providing end-to-end platform for AI application security, and you're doing this from more of the offensive side.
Mhm.
But together we're trying to get at AI security.
Yeah, yeah. I mean, that's what defines security in every other subspace. It's attackers informing defenders and defenders pushing attackers, and the goal of everything is just to come to better solutions. And we've solved a ton of amazing problems on the security end. I mean, you can't go to a website anymore and throw a tick mark in a login page, and there's a reason for that. And it's because a lot of people came together and like worked hard to establish better standards and processes and testing strategies, and share their expertise with each other. And so yeah, I think I'd really love to see AI be one of the first technologies where we feel like we solve security at the right time as opposed to late, as it usually comes with security. And I'm optimistic for that future. I don't know if it'll come, but I think we're on a pretty good track right now, regardless of whatever missteps we might make. So
Amazing. Amen. Thank you, Nick.
yeah,
Nick
yeah, no
Landers,
worries.
thank you for joining us today.
Yeah, you're welcome. Thank you for having me.